This video is going to go through the first few questions of the International Pearson C34 paper of January 2016. For home students, this should also be useful. The C34 paper is a combination of C3 and 4. I will try to remember as I go through to basically refer to the actual module this would be on. Because all the questions could perfectly well be on home papers, they would just be on C3 or C4. The first one would be a C4 question because it's binomial. There is a binomial in the C2 formulas. There is the binomial expansion written. I don't know exactly how it's written, but it's probably going to be, well, something like this: 1 over nx. I'm not sure if they put the 1 factorial underneath there or not. Obviously 1 factorial is 1. n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed, and so on. Oh, I don't know what the x cube's done appearing on the bottom there. Anyway, and so on. So in order to use this expansion, we need to make sure that that front number there is 1. So we need to take care with that, otherwise it's pretty straightforward. So 3 minus 2x to the minus 4 is equal to, let's take 3 out as a factor, but remember it's 3 to the minus 4, and then that's 1. Dividing this by 3 is over 2/3 x to the minus 4, which explains why the validity is 3 over 2, by the way. It has not asked for validity here, but that's why, because this has to be greater than minus 1 and less than or equal to 1 to be valid, which would mean that x has got to be greater than or equal, well, it means that. Okay, so now we can just work with this. 1 over 3 to the minus 4, we really perhaps, not 1 over, 3 to the minus 4 is equal to 1 over 3 to the 4, and 3 to the 4 is 81. So that's the kind of thing that personally I'd be just doing a calculation in my head, although not many of my students do that, but there we go. It's 1 over 81. 1 minus 2/3 x to the minus 4. Right, so now we can do the expansion, this thing here. So it's 1 over 81, and the first term is 1, plus, now obviously n is minus 4 here, so that's minus 4x. Let's write it out, plus minus 4x, and then plus minus 4 times minus 5, because that's n minus 1 over 2 factorial x squared. There is no need, or no, I've obviously talked about x, but obviously x in this case is minus 2/3 x, and that's minus 2/3 x there as well. Okay, so that equals to 1 over 81, and then that's 1 plus 8 over 3x, and then here is going to be, we've got quite a bit going on here. That's going to be 20, so it's going to be 10 there. This whole bit, it'll be 10. Notice I'm doing it without a calculator, it's just a habit I've got. So then that's 4 over 9, so that's 40 over 9. Notice they're all positives here. That's because we're always having an even number of negatives in our expansion. I should times out the 1 over 81 as well now, so I get 1 over 81 plus 8 over 243 x plus 40 over 729 x squared. Okay, nice gentle start to the paper. Not too much problem with that. Okay, let's have a look at question 2. Okay, so question 2 is a trig question. Would be on C3 if this were a home paper, because it's entirely trig. So this wouldn't really come on C4, although you need trig for C4. Well, the first part is only 1 mark, and all we're doing is we're replacing the cot squared here with, because we've got 1 plus cot squared x equals cosec squared x, which is one of the identities that you need to know. So that means for part A, we have 1, I said I've written cos, but I mean cot, so that's 1 cot. That means that cot squared x is cosec squared x minus 1, cosec squared x minus 1 minus cosec x minus 11, because that's my cot x that I've got, cot squared x that I've got there, equals 0. So therefore cosec squared x minus cosec x minus 12 equals 0. We can leave it there because it hasn't said stating the value of k, it's just said right, may expressed in that cut form where k is a constant, but if you're kind of worried then just write k equals minus 12, but actually you wouldn't have needed it here because it hasn't said find the value of k, it said express it in a form where k is a constant. Anyway, so that's just 1 mark, very straightforward. Now, what that means is we can factorize this. Now, I'm going to put this into 2 brackets. Cosec x minus, it's going to be minus 4, and cosec x plus 3. Now, some students don't like just going straight to that, and so okay, if you want, I'll just do this. You can let cosec x, surprised how comforting some students find this, so that cosec x be equal to y, say, and so then we've got y squared minus y minus 12 equals 0, y minus 4, y plus 3 equals 0, and then go back to there if you want. But I'm not encouraging that, I'm just saying it's okay if that makes you happy. Okay, so there we go. We can we're now very close to being able to solve it because we've got our 2 factors. We have cosec x equals 4 and cosec x equals 2 minus 3. So here, that gives us sine x equals to 1/4, and sine x equals to minus 1/3. Okay, so let's follow the sine x first of all. Those of you who know I'm not a big fan of making a big fuss about solving my trig equations with cast diagrams or even graphs. We should know that if we find a principal value for the sine, not for everything, but solving for sine, let's write it up here in red. Yeah, so what we do is we find a principal value, that's the value that the calculator gives you. It's going to be the value that lies between, in this case, minus 90 and minus 90. Okay, you find that principal value there, and then you find the other solution, or secondary sometimes called, for sine is 180 minus that. So in other words, for the sine graph, you can find one value which is a principal value and the other one which is 180 minus principal value. It's all based around the fact that there's symmetry around 90 here. So if we have one solution Here we're going to have another solution, 180 minus it, okay, because of the symmetry of the sine graph. Then any other solutions, so add multiples of 360 if necessary. 360 if necessary. Let's rub this off now. Don't need that anymore. To either or both. Okay, so that's how it works. So I just thought I'd mention that. I think some people like the graph and cast because it kind of covers, or particularly the cast, because it covers all of them. It's like a one-stop shop, but really I find it a bit slow, to be honest. You might think, well, you're taking a while, but I'm only taking a while to explain it. It wouldn't take me long to do it, as you're about to see. Okay, let's deal with this one first of all then. So we find a principal value, which is inverse sine of 1/4. So that's inverse sine of 1/4, which gives me 14.5. The secondary solution is 180 minus 14.5, which is equal to 165.5. Okay, done, because we're within the range 0 to 360. If I add 360 to either of these, I'm going to go out of the range. So that's done for that one. Okay, this one, principal value, is equal to minus 19.5. Okay, so you say, oh, it's not in our range. So we deal with that. Our secondary is 180 minus that, but don't forget the double minus, obviously. So 180 minus 19.5. So that's 199.5. So we've got our two solutions here, minus 19.5 and 199.5. And as I said, if necessary, we're going to add multiples of 360 because we want to be within our range. So we add 360 to that one, and we get 340.5. So this one actually is not required, but it doesn't matter if we list it. Now, that's probably what I've written would be okay, but I'm going to, make life easy for myself and just put everyone's mind at rest that we know what we're doing. I'm going to write the numbers consecutively: 14.5, 165.5, then 199.5, and 340.5. Okay, that is the answer. Okay, let's go on to question 3. Okay, so this would be on C4. It's implicit differentiation. It's a little bit of a sting in it, a bit irritating, to be honest. We've got this differentiator here. Now, there is a formula for it in the C3 formula sheet, so probably most of you would be happy to just use that. I'm going to take myself back to the early 80s when I had to, I wasn't given the benefit of knowing how to remember, just copying things from a formula and just demonstrating it. Imagine we were differentiating that by itself. Then we take logs both sides. So that's ln y equals to x ln 3. Now we might want to think of that as ln 3x, because this is just a constant. So then if I differentiate, I get implicitly, I differentiate the ln y, which is 1 over y, but I need to times by dy by dx, because I'm differentiating with respect to x. So probably like that. And then we've got ln 3 as our answer. Dy by dx is equal to ln 3y separately, but ln 3 itself is equal to y is equal to 3 to the x, so that's ln 3 to the x. Okay, some of you are wondering perhaps why I bothered, because there is a formula, I believe, that might help in the C3 formula. I don't think it gives exactly that. I'll just have a quick look at it. So that's the formula in the C3 formula book. Some of you may decide to deal with it using that. Differentiating a to the x means that basically we've got the ln a times by that. So we have ln a times by e to the x ln a. But then of course e to the x ln a is also equal to a to the x. So some of you might choose to use that. I'm not in the habit of doing that, but that's what some students do. And others just, because it's the kind of thing that doesn't crop up that often, so you might not remember it off by heart. I'm not sure I do. I tend to do something like this, but much quicker than I've just been chatting on now. But some people might just want to learn this, and it really is up to you. You just have to deal with it in your own way. D by dx ax is equal to ln a to the x. Take your pick. What are you going to do? Are you going to do this quickly? Obviously. Are you going to do this? Or are you just going to remember this? One way or another, you can't be left in the exam thinking, oh, what do I do here? Okay, so, and it is an Edexcel thing. They seem to like the a to the x thing with both differentiating and integrating for some reason. Anyway, so let's do the differentiating bit now. So we're actually going to start doing the question, right? Okay, so let's get on with it. Okay, we're going to differentiate each term. 3 to the x is differentiated. I've just done that. Hopefully, I don't have to make too much of a song and dance about it now. Okay, that's 3 to the x. Okay, plus 6y. Now don't forget we're differentiating with respect to x, so that's the incorrect answer will be 6. It's 6 dy by dx. Now here we're going to use the product rule. Okay, now I can, again, you might not necessarily see me write it out if I was to do it, or I might just allow a bit of space for those who... So we let u equal to 3 over 2xi and v equal to y squared, and then you've got du by dx is 3 over 2, and dv by dx, you've got to be careful here because you're differentiating with respect to y, so that's 2y dy by dx. And because you're doing the product rule, we're multiplying that by that and that by that. I'm just going to write that in here. We've got 3 over 2x times by 2y dy by dx. That's that by that. Plus 3 over 2 y squared. Okay, let's tidy that up a little bit. Ln 3 to the x plus 6 dy by dx. I'm really only dealing with this middle term, this term here with the 2 bracketed thing here. The 2 cancels, so we have 3xy dy by dx plus 3 over 2 y squared. Okay. Now it says find the exact value of dy by dx at the point where the coordinates are 2, 3. Whenever you're given coordinates, I tend to substitute now rather than rearrange to get dy by dx as subject. If we're asked for a particular value, then I would sub it in now, but it's okay to get dy by dx and then sub in, but it just means we're dealing with a fraction later there and so on. So sub 2, 3. So we're going to sub 2, 3 in, and we have ln 3 times 3 squared plus 6 dy by dx plus 3, equals 3 times by x, which is 2 times by 3, plus 3 over 2 times by 3 squared. Okay, so that gives me 9 ln 3 or I've forgotten a term in dy by dx there. So that also obviously forgot to put in the 3 squared. Sometimes just rush these things through. You do have to get a bit frantic at times and make mistakes just in a rush to try and get as much done as possible. That's what students do in the exam, really. I kind of relate to that. So that's 6 dy by dx, 18 dy by dx, plus, and this is going to be 9/27 over 2. Okay, so at this stage we can write in terms of dy by dx. I might be inclined to times by 2, or maybe not. Let's have a look. Yeah, okay, let's do that. 18 ln 3 plus 12 dy by dx plus 36 equals 36 dy by dx plus 27. So now we can take the dy by dx's together and we end up with 24 dy by dx, or let's cancel a factor of 3 now as well, I think. Let's do that. Just make the numbers a bit smaller. If I divide that by 3, I get 6. Divide this by 3, I get 4. Divide this by 3, I get 12. Divide this by 3, and I get 9. So now I can bring it all together. And I get 8 dy by dx. The two terms in dy by dx combine. That then leaves the positive bit 6 ln 3. Take away 9 over 8. However, normally it would be fine to give it in that form, but we do need to read the question. It wants the ln by itself with no constant in front of it. So, let's get rid of that 8 there. So that means that dy by dx is equal to ln 3 to the 6 minus 9 all over 8. So that's ln 729 minus 9 all over 8. Okay, and then that's it. We've got it in the correct form there. Okay. Where a is minus 9, and if you want a is minus 9, if you want to be, and b is equal to 729. If we want to be kind of particular. Right, okay, I think we'll do one more on this video before we're done, because we're 23 minutes in and we've been through quite a bit. I might be waffling a bit too much. Okay, let's just do question 4. So this would be on a home paper C4 question. It's a pretty straightforward volumes of revolution question. We know that the volume of a revolution is pi times by the appropriate limits. Okay, times by y squared dx. Okay, so that's the volume, and so the first part's going to be pretty straightforward. No, but there's a slight twist which in part B, which we'll look at in a moment, but nothing too much to worry about, I wouldn't have thought. So we've got the volume. It does say 360 degrees. I've never seen them. Well, can't remember them ever saying 180 degrees or whatever, in which case it would be half of that or whatever. But anyway, volume is pi integration between 2/3 of minus 1 to 4 plus 3x squared dx. Okay, now that's not too difficult. We just can square that out and we get pi 2/3 minus 1 of 4 over 4 plus 3x squared dx. Right, now I might take the 4 out. Doesn't really matter, but I do tend to be in the habit of taking any constants out of my integration. So we're integrating that. Now, I hope you're not... so many of my students are at a LUN here because they get so used to, first of all, fear the LUN, and then they start liking it and want to call everything a LUN. This is just our normal x to the n is equal to, integrating x to the n is equal to n 1 over n plus 1 x to the n plus 1. The kind of reverse chain rule aspect of that, because we're going to end up dividing by 3 because of the 3 there. So it's going to be 4 times by 1 over 3 because of that 3. But also n plus 1, well look, that's the actual value of n here, be careful, is minus 2. So add that to it, that's 1 divided by minus 1. And 4 plus 3x to the minus 1. Between the limits 2/3 and minus 1. Okay, it's reverse chain rule. You can check by differentiating because we know we're going to have to add 1 to the power. So you can check when we get our final answer. We better tidy that up before we integrate. That's going to be minus 4/3 4 plus 3x to the minus 1. I am in the habit of checking, as I say, check that when we differentiate that using the chain rule, we get that. Okay, some people use that as their way of doing it. What they do is they just look at, they kind of compare what this is differentiated. They know it's of that form because they're adding 1 to the power. Differentiate that and see what constant comes in front and therefore work out what they need to do. I tend to more likely do this. Divide by the value a because it's reverse of what you would do for its reverse chain rule, and then that's just the normal n plus 1 rule there. Okay, so when we put that in, I've forgotten to leave the pi, take the pi out. It's quite a common little slip as well when you've got a few things on your mind. Okay, so that equals to pi brackets minus 4/3, and putting 2/3 in there, that will be 4 plus 1 to the minus 1. No, it won't because it's 2/3, so it's 4 plus 2 to the minus 1. Minus, but that's going to make it actually plus, because there's 2 minuses, 4/3, 4 plus 3 to the minus 1. So this is equal to pi times minus 4/3, 1 over 6, plus 4/3. Oh, so I've put a minus 1, another slip here, so that should be minus 3 there. So that makes that 1, so it just makes it 4/3. So that makes this number pi times, cancel that down, that makes that pi times minus 4 over 9, minus 2 over 9, plus 4/3, put it over common denominator, that's 8 over 9, so that makes that equal to 10 over 9. I beg your pardon, I'm making too much of a fuss of this. I know most of you use calculators anyway, so haven't done C1 anymore, but this number, of course, is 12 over 9. So the final answer is 10 pi over 9. It did insist on, oh no, it hasn't. It probably does want an exact answer. Okay, right, now here's a twist in part B. We've got some shape which is obviously kind of rotated around, so this is the base here, corresponds to this base here. Okay, and it tells us that AB is 15. Here, this value here is equal to 1 plus 2/3, so that's 5 over 3. Okay, so there's a scale factor involved here. If we find a scale factor, some of you might, I haven't taught GCSE for about 10 years, but I remember this being quite a thing. So scale factor is equal to because this length is 15 and this is 5 over 3, so it's 15 over 5 over 3, and that equals to 9. But of course the volume won't be 9 times bigger because it's a volume. The volume will be 9 cubed times bigger, so the volume will be equal to 9 cubed times by our 10 pi over 9. So that makes the 9 cubed cancels with 9 to give 9 squared, which is 81. So it's 810 pi. It doesn't ask for a certain number of decimal places or anything, so I think the exact answer would be fine. But just to be cautious, I might tend to work that out, and that gives 2545 centimeters cubed. Give both. But yeah, it doesn't ask for a number of decimal places, so the exact answer in terms of multiple pi would surely be fine. Okay, so we've done the first 4 questions. There's quite a lot to do because they're 2-hour papers, these. So we're gonna just look at the number of questions that there are. There's 13 questions. It's going to come at least 3 parts, but this is part 1 done. I hope you enjoyed that. Bye.